So here we are, rationalizing the denominator. The key idea of these notes in here is that the idea is that a denominator in the rules of math should not have a radical in them, or a root. Okay, so in that case we have to figure out ways of getting rid of a root in the denominator. So as we've seen before, what happens is if you take a radical or a root and, for instance, have a 3 underneath, if you multiply that by another radical with a 3 underneath, same radical, you're going to end up being able to write it as a 3 times 3 in one of the roots. And then, of course, we know that 3 times 3 is 9, and then what's the square root of 9? Okay. So the interesting part about this when it comes to rationalizing the denominator is that if you have a denominator, say for instance like our first example of square root of 3, if you multiply by another of the same, a square root of 3, you actually end up with just that number back out again. So that's what we're going to do here. In this first example, what I'm going to do is multiply by the square root of 3 over the square root of 3. Remember that it does have to be the same thing over the same thing because technically that equals 1, okay? But the idea here is that if we multiply by the square root of 3, at least in the denominator, these two pieces being multiplied by each other are going to result in a 3 in the denominator. Now the numerator, of course, does not necessarily get less tricky, but that's not the point of rationalizing the denominator, okay? So we are just focusing on making that simpler versus the numerator. So the numerator then is just going to be 3 next to square roots of 3, and that is our rationalized answer. Okay, so the whole idea is take the denominator and multiply it as a form of 1 to the top and the bottom, and then simplify. What's different about these next ones is that you have a complex kind of solution up here. It's okay if you have two pieces, a rational and an irrational piece. We just use it as, like, for instance, 4 plus x. So what's going to happen is if we multiply it in, we're going to multiply whatever it happens to be into both of those pieces. We're going to distribute. So this one here, I'm going to multiply by a form of 1, and since the denominator is the square root of 7, that's what I'll be multiplying by. So don't get confused by a numerator that might have a square root as well, because it turns out that square root of 3 is not what we're looking for. Again, we're trying to do the denominator, so go to that first as your choice. So then we're going to distribute that square root of 7 to both of these pieces. So that means that we're going to have 4 square roots of 7 plus square root of 3 square roots of 7, and all of that is going to be over 7 from square root of 7 times square root of 7. From there, we will try to simplify as much as possible. So if we look at our pieces here, 3 in a square root and 7 in a square root can actually be written as 21 inside of a square root. Double check that there's not any perfect square that could come out of 21, and that's kind of how we'll leave it. So if you can simplify this piece at all, like take out a 16 or whatever, that would be lovely, but of course we don't have any of that in this set. So that is our solution there. Again, not necessarily easier, right? But the denominator has been what we're calling rationalized, and so that is our solution. Alright, so our next piece here, and again we're trying to rationalize the denominator, is going to multiply by a form of the root that's in the denominator. And so we don't actually need to multiply by 4 square roots of 6, because 4 is not the thing that's in a radical. So we're actually going to be multiplying by a square root of 6 over square root of 6. Just a radical part, or the root. Alright. So, in the top we are distributing again, and so if we look at what we get, negative 4 times square root of 6, and then we'll add to that square root of 3 times square root of 6, and our denominator is going to be 4 square roots of 6 square roots of 6. So remember that the 2 square roots of 6 by each other makes us just a 6, and then we could rewrite this here as one radical. So if we rewrite, the first piece kind of stays the same. The second one becomes 1 radical of the square root of 18, and then the denominator becomes 4 times 6. Continuing to simplify, the negative 4 square roots of 6 stays the same, but if we take our time to rewrite this so that it's as simple as possible, I realize that a 9, which is a perfect square, can divide evenly into 18, and so I'm going to rewrite this as 9 times 2. And of course the denominator can actually be 24 instead of 4 times 6. Continuing with that top piece there, we have negative 4 square roots of 6, but now we're going to add that to square root of 9 times square root of 2. And remember that the square root of 9 is actually 3. So our final answer is negative 4 square roots of 6 plus 3 square roots of 2 all over 24. And the reason of rationalizing the denominator, again, is so that that rule of you can't have a square root or a root in the denominator ends up being possible. So I have been saying quite a few words here, so I just want to note that a radical kind of is the main idea of types of roots. Okay, and the roots can actually be things like a square root, and a cube root, and then after that we go with fourth root and fifth root, so there's not really a nice word after that. So radicals, again, are kind of that main idea. We also call them roots because notice the word after each of them, right? And then, of course, there are types of roots. So as we're looking through them, there's a square root, which is assumed to have a 2 technically right here, but it's just that we use it so often that we don't put the 2 there. And then there's a cube root, which means that you're actually trying to find out what times itself 3 times makes the thing inside. And then a fourth root, of course, would have a little 4, and a fifth root would have a little 5. So radical is the sum of all of them, and they are all roots as well because of the fact that they all have that word. And then depending on what's happening, there's the subset of square roots, cube roots, fourth roots, all of that. So that's our notes for today. And so for your assignment, you'll of course finish the rest of this worksheet.